Ok, donc bonsoir à tous. Je suis Mademoiselle Ima. Donc aujourd'hui, ce topic, l'Hydro Circular Measure. Donc, m'explique vite comment il peut passer aujourd'hui. C'est-à-dire, je faire une lecture de 2 hours jusqu'à 9h30. In between, je peux donner 10 minutes question time. Ou si c'était n'importe quelle question, comme je peux faire lecture là, je peux écrire dans le chat. During the question time, vous pouvez répondre à cette question. Et aussi, à la fin, pendant encore une 10 minutes break, que je donne les temps pour je pose question. N'importe quelle question, je tiens l'eau, circular measure, ou l'eau, c'est qui m'en expliqué. Ok? Donc, maintenant, nous allons commencer. Donc, first part, l'eau circular measure, living law. What is the radian? Definition of the radian. Donc, radian measure. Donc, c'est quoi? What is the definition of the radian? The radian is the angle subtended at the center of a circle by an arc of length equal to the radius of the circle. Donc, si je draw un circle, it has radius R, center O, donc the radius is R, the center of the circle is O, and this is the angle. Donc we want to define the angle as the radian. Donc d'après définition, the radian is the angle subtended at the center of the circle by an arc of length equal to the radius of the circle. Donc 1 radian is equal to, this is the arc length. The length of the arc, we denote it as S. Donc normalement, comment nous find an angle? Si nous avons radius avec nous the arc length, the angle is defined as, donc let's call the angle theta. Theta is defined as S over O. Now we will define 1 radian. Donc d'après définition of theta, we will say that 1 radian is equal to the arc length over the radius. Mais comment on trouver là-haut? It is the angle subtended by an arc of length equal to the radius of the circle. Donc si arc of length is equal to S and the radius is equal to R, then we know that S is equal to R for the radian. Donc si je remplace S par R, je trouve qu'il me gagne 1, and the 1 corresponds to 1 radian. We can also denote 1 radian as 1c. Donc sa langue ici là would be 1c, where S is equal to R. Donc c'est ça, the definition of the radian. Donc where S is the arc length and O is the radius of the circle. So that was the first part of this lecture. The first part is about knowing c'est quoi the radian. Parce que dans sa topic circular measure là, nous poussons à vivre plus the radian dans place degree. For us to be able to make use of circular measure, we need to make use of the radian. Donc, we can continue now. Next, donc in general, if the length of the arc is S units, as we can see here, the arc length is S, c'est-à-dire the length of this arc. Is S units, and the radius is R units. So as we can see here on the diagram, the radius is R units. Then we can say that the angle theta is equal to S over O. That is, it is a ratio. This is an important definition. So the angle is a ratio of the arc length to the length of the radius. So this is the definition of an angle when we have the arc length and the radius. Donc nous faisons un petit exemple pour ça. Donc comment nous servir theta is equal to S over O. So example, find the value of theta in radians if S is equal to 3 centimeters and O is equal to 2 centimeters. So to be able to find the value of theta, we will have to make use of the formula theta is equal to S over O. Donc let's apply this formula. Theta is equal to S over O. Donc S, you know that it is equal to 3 centimeters and O is equal to 2 centimeters. Donc nous juste n'importe place dans l'équation là, and then we get theta is equal to 1.5 radians. Okay, it's not degrees but radians. Okay, donc before we continue, me donne une minute pour screenshot sa première partie de lecture. Parce qu'il me va provide cette note ça après, donc je vais screenshot à mon screen. Ok, donc maintenant on continue. Juste avant qu'il ne continue, donne une note. Baser l'eau signifie faire en haut. Donc, note. O and S are measured in the same unit. Thus, the radian measure of an angle is a number without dimension. Ça veut dire quoi dimension? Dimension veut dire unit. It's the same thing as unit. Although the word radian is often added. So as you can see above in the above example, it's 3 centimeters divided by 2 centimeters. Donc, je trouvais que centimètre avec centimètre coupé, and you have 1.5, and it's dimensionless. Usually you don't have any units, but même ça nous servait the word radians. Même s'il est dimensionless, that is, it does not have any unit or any dimension, we use the word radian to show the difference between c'est quoi radian et c'est quoi un degree. Now, next part, we will show the relation between the radian and the degree measure. So, relation between radian and degree measure. So, this is the second part of this lecture. So, consider consider the angle theta in a semicircle of radius O, as shown below. Donc, let's draw the semicircle. So this is the center of the circle O. Its radius. The radius of the circle is O, and this is the angle theta. Et tout ça, from here to here, is known as S, that is the arc length, qu'on a fait trouver dans la première partie de sa lecture là. So we know that for a circle, the circumference, which we can also call S, is equal to 2 pi r. But for a semicircle, the arc length or the circumference S is equal to half of 2 pi r. That is, it's equal to pi r. This is for a semicircle. Now, we know that, donc nous fait prouver là-haut que en haut, on peut trouver que theta, ici là, theta is equal to S over O. Here, so let's make use of this to prove the relationship between radian and degree measure. Donc, we know that theta is equal to S over O. And, donc nous fait trouver que for a semicircle, theta is equal to pi O. And we divide by O. Donc, therefore, this angle theta of the semicircle is equal to pi. Okay, because O and O cancels out. Mais nous connaissons que for a semicircle, long the angle theta is equal to 180 degrés. Donc in degrees, nous déjà connaissons que theta égale 180 degrés. Donc therefore, the relationship between radian measure and degree measure is that pi radians is equal to 180 degrees. This is the relationship between the radian and the degree. Donc, si on fait un table of the radian and the degree, where we can compare the angles, okay. Donc, let me write down some of the angles that you're already aware of. Par exemple, so we will convert from degrees to radians. Donc, bonne langue qui nous servit plus souvent dans degrees, 360 degrees, 270 degrés, 180 degrés, 90 degrees, 60 degrees, 45 degrees, 30 degrees, and also we have the last one, 0 degrees. Yes, so 0 degrees. Donc, nous fait trouver qui pi radians les 180 degrés. Donc, pour 180, we will have pi. Pour 270, we will have 3 pi by 2. For 360 degrees, it is equivalent to 2 pi. And for 90 degrees, it's equivalent to pi by 2. 60 degrees, it's equivalent to pi by 3. 45 degrees est pareil comme pi by 4. 30 degrees, it's similar to pi by 6. And 0 degrees, it's similar to 0 degrees. 0 degrees, sorry, is similar to 0 radians. Donc, comment on gagne tout ça dans les autres langues en radians là? On servi this formula, elle est là par proportion, on gagne dans les autres langues. Okay? Mais juste avant que je vous montre comment nous gagnons ça dans les autres angles là, you have 1 minute to screenshot ça dans notes là. Ok, donc maintenant nous continuons. So, comment nous convert from degrees to radian et comment nous convert from radians to degrees using this formula qui nous fait gagner que pi radians égale 180 degrés. Donc, let's see. So, we know that pi radians is equal to 180 degrees. So 1 radian would be equal to 180 degrees divided by pi, and this is approximately equal to 57.3 degrés. So we have the first relation entre comment vous convert from radian to degree. Donc, if ever vous êtes pour convert something in radian into degrees, vous êtes multiplié par 180 low pi. This is the first relation. The second relation, to convert from degrees to radian, donc we will still use que pi radian égale 180 degrés. So we know that 180 degrees is equal to pi radians. So 1 degree would be equal to pi over 180 degrés, which is approximately equal to 0.0745 radians. Donc, si c'était là pour convert from degrees to radian, you have to multiply either by pi log 180 degrés ou tout simplement juste multiply by 0.01745. Then you will get your answer in radians. So let's do an example on these, on how to convert from radian to degrees and from degrees to radian. So example, convert 23 degrees in radians. So as you can see above, 1 degree is equal to pi log 180 radians. Donc, quand on convert 23 degrees into radians, so I will do 23 degrees is equal to pi log 180 fois 23 degrés. Okay? So therefore, si je tape ça au calculatrice, I will get approximately 0.4 radians. Maintenant, on fait un exemple similaire, sauf que là, nous pouvons convert from radians to degrees. Donc, next example. Convert 1.5 radian in degrees. Donc, let's see dans nos relations qui nous sont. Yes, so our relation says that 1 radian is equal to 180 degrees over pi. Donc là, qui vous a fait, vous a multiply by the value qui nous donne in radian, me multiplier par 180 low pi. Donc ça veut dire 1.5 radian would be equal to 180 sur pi radian multiplied by 1.5, donc this is in degrees, radian. My answer should be in degrees, donc je vais faire à peu près 270 degrés sur pi, which is approximately equal to 85.9 degrees. Donc you can check this using a calculator. So this is how you convert from degrees to radian and radian to degrees. Now, the next part is on arc length, that is, nous fait trouver là-haut c'est quoi arc length. S is the arc length, the length of the arc of a circle. Yes, so we will find the, comment nous cave CV arc length dans une question et aussi area of a sector. Okay, so next part is on arc length and area of a sector. So from the definition, of the radian, nous trouvons que en haut, let's go back up, that theta is equal to S over R. That is, theta is equal to the arc length divided by the radius. So from the definition of the radian, we know that theta is equal to S over R. Now, donc, and therefore, we can say that we can find plutôt the arc length S, donc therefore, the length of an arc is given by S is equal to R theta. Donc, comment on get ça? I just cross multiply here. Donc, m'envoie R de l'autre côté, I get S is equal to R theta. So this is comment nous gain the arc length, where it is to be noted that theta is in radians. And not in degrees. Okay? Donc, toujours before we continue, I want you to screenshot this part. Okay, let's continue now. So we have seen that S is equal to R theta. Yeah. Donc, nous service our relation S is equal to R theta là dans un exemple. So, for example, if theta is equal to 2.1 radians and R, that is the radius, is equal to 3 centimeters, find the length of arc. Donc, comment nous faire ça? Dit simple, we just apply the formula. So we know that the length of arc, which we usually denote as S, is equal to, donc nous fait trouver là, ici, que S is equal to R theta. Donc, what is R? R, we know that it is 3 centimeters. Et theta n'est donné dans question là que c'est 2.1 radians. So if we multiply, we get, and it's in centimeters. Okay, Avant, en haut, nous disait que radian, it is a dimensionless unit. Donc, il n'est pas vraiment compté as a unit. So, only the unit of centimeters that counts. Donc, therefore, nous pouvons gagner 6.3 centimeters. And as you can see, both the length of arc and the radius have the same unit. That is, they are both in centimeters. So note, S and R have the same unit. Ok? Parce que je déjà connais since the radian is dimensionless. Ne fait que dire là. Ok? Now, this was juste comment servir formule. Là, nous avons un vrai exemple de comment une question politique, une question d'examen surtout. So, example. The diagram shows part of a circle, center O, radius or centimeter. Okay, so in this question we are asked to calculate first part the value of O, that is the radius, and secondly angle BOC in radians. Donc, let's see the diagram qu'il donne nous avant. Donc, this is the diagram, a circle. Okay, so it shows only part of a circle. The center of the circle is O. So let's say O is here. And the radius of the circle is O. Donc ça, O, this is O, this is O. This is A. And this is B. Sorry. This is B here. And the last part is C. Et dans le dessin-là, il dit comme ça que this is equal to 2.4 centimeters. This part here is equal to 1.4 centimeters. And this angle here is given as 1.2 radians. So, we have the drawing. And we are asked to calculate the value of R. Donc, let's, yeah. Yes, so we are asked to calculate the value of R in the first part. So let's try it. Donc, pour first part, we have to calculate the value of R. Mais nous connaissons une relation nous. S is equal to R theta. Et dans sa relation là, nous can find R. Mais pour nous find R, nous avons the value of S, that is the arc length, and the value of theta. Donc, let's study the diagram first. So, let me write the relation S is equal to R theta. Dans le diagram, nous connaissons this angle theta, and we also know this arc length, which is 2.4. Donc, we can consider the triangle, sorry, not the triangle, but the sector AOB. Donc, in the sector AOB, S is equal to 2.04 centimeters and R is equal to the value that we are to find, and we have also theta is equal to 1.2 radians. Donc we have this, and we need to find this. So we can use this formula. Donc directement we replace S is equal to R theta. This implies que R will be equal to S over theta. So S, we know that it is 2.4 centimeters and theta is equal to 1.2 radian. Donc therefore R is equal to 2. So this is the value of R. That is the radius of the circle. So we can just write R, the plus R, we can just write 2. R is equal to 2. So this was the first part of the question, find the value of R. Next we have to find the angle BOC in radians. Donc angle BOC is this. Donc nous fait trouver qui R égale 2 et nous aussi on a que the length of the arc BC is equal to 1.4 centimeters. So we can definitely find the angle BOC, this angle here. So let's find it. Okay, donc before we continue, I want you to screenshot this part and then we'll continue. Okay, so let's continue with the second part of this question, that is to find angle BOC in radians. Yeah, so we know that in sector BOC, S is equal to 1.4 centimeters and R, qui nous fait trouver the first part of the question, is equal to 2 centimeters. So we just have to make use of the relation S is equal to R theta. And we need to find theta, of course. That is the angle BOC. Donc theta is equal to S over O. Theta here, dans sa situation là, it is equal to the angle BOC. Donc BOC is equal to S over O. So what is the value of S? S is 1.4 centimeters and the value of R is equal to 2 centimeters. Okay, so therefore angle BOC is equal to 0.7 radians. And we'll complete the question on how to find the radius and angle using the just one formula, S is equal to R theta. Okay, donc next part is on finding the area of a sector. Donc nous pourrons formulate area of a sector first, et puis then we will use it in examples. So next part is on area of a sector. Donc to draw, we'll start by drawing a circle. So we have a circle. The center of the circle is O. The radius of the circle is R, and we call the angle theta. The arc length of this sector is S. Donc this is the length of the arc, S. And maintenant, the area, this area of the sector, we call the area A. Okay, donc now we will derive a formula for the area of the sector. Donc in the diagram, the angle of the sector, donc let's give the sector a name. Here it's P, here it's P, et ici it's Q. Donc the angle of the sector POQ, okay, is theta radians. Okay, comme on a dessiné au diagram. Maintenant, by proportion, we can see that the area of sector POQ over the area of the circle is equal to the angle in the sector divided by the angle in the circle. So what is the area of the sector? The area of the sector in fact denoted as A. And we know that the area of a circle is pi r squared. Now, the angle in the sector is theta. And the angle in the circle, we know that a circle makes 360 degrés. Et comme on nous disait tout à l'heure là, 360 degrés, it corresponds to 2 pi radians. So, we will write everything in radians. Donc là, angle in the circle is 2 pi. Donc 2 pi, c'est 360 degrés. Donc maintenant, si nous faisons area of the sector subject formula, that is A, would be equal to theta over 2 pi times pi r squared. Donc this simplifies to A is equal to half r squared theta. Donc as we can see that pi et pi coupé reste 1 over 2, donc half r squared and theta. Okay, donc before we continue, take a screenshot of the screen. Ok, donc on arrive in the middle of our session. Donc maintenant c'est question time. Si vous avez une autre question, vous pouvez unmute ou vous pouvez send cette question par chat. Donc vous avez une question so far? Et dans une question se pas comprendre ou anything? Donc, si je n'ai aucune question, je tenais 10 minutes pause. Donc, 8h34, là, nous répond. Sinon, si vous avez une question, feel free to unmute and or to send a message via the chat. Ok, donc nous continuons maintenant. Yes, so we have just proved that the area of a sector is equal to half r squared theta. Donc ça, c'est a very important relation, and to note that theta is in radians toujours. Ok, mais nous can faire aussi encore une relation for area. So we have two relations for area. As we know that S is equal to R theta, we have donc A is equal to, qui nous fait trouver la half R times R theta, but we know that R theta is simply S. Donc therefore we have A is equal to half RS, and where R is the radius of the circle and S is the arc length. Donc the length of arc of the sector here. Donc là, nous avons two relationships for area of a sector. Number one, we have A is equal to R squared theta. C'est-à-dire nous can find area si nous avons radius avec long. Ou, maintenant, fait moi, nous pas nous na radius, mais nous pas long, mais nous na arc length. Then we can use the second formula, that is A is equal to half RS to find the area of a sector. Donc, let's see comment nous casse servir ça dans un exemple. So, example. Yes. Example. A sector cut from a circle of radius 5 centimeters has a perimeter 16 centimeters. We need to find the area of this sector. Donc, let's see comment the sector is. So this sector has been cut from a circle. Okay, the radius of the sector yes, so the radius of the sector R is equal to 5 centimeters. So both sides R will be equal to 5 centimeters. This we know we can denote this as S, donc the length of the arc of this sector. And we know that the perimeter, that is the perimeter to do ça, donc S plus the radius here and the radius here is the perimeter, is equal to 16 centimeters. So using the perimeter, we need to find the area of this sector. Donc, we know that the perimeter of the sector is equal to 16 centimeters. Et nous connaissons comment calculer le perimeter. Perimeter is R plus S, which is equal to 16 toujours. And we know the value of R. R is equal to 5. Donc 5 plus S would be equal to 16. This implies that 10 plus S is equal to 16. And therefore, S is equal to 16 minus 10, which is just 6 centimeters. Donc, nous aussi find the value of which is 6 centimeters. Donc, we know R, we know S, and we need to find A. Donc, from A is equal to half R squared theta, and A is equal to half RS, formule qui me trouve peut marcher ici, because we know we need to find A, we know R and S, we will use this formula. Donc A would be equal to half RS. Donc area of the sector is equal to half RS. R is given to us as 5 centimeters. And S is equal to 6 centimeters. Donc, nous fait trouver que S égale à 6. So, finally, we get, donc, 1, 3. The area of this sector is equal to 15 centimeters square. Ok? Donc, c'est comme ça qu'il nous décidait quelle formule nous servit. We need to know which parameters are given to us. Par exemple, dans ça exemple-là, R and S is given to us. Donc là, nous connaissons qu'il nous a servi formule A is equal to half RS. Si par contre, dans un autre exemple de nous R, de nous theta, et then nous find the area of a sector, then we will use the first formula, that is A is equal to half R squared theta. Ok? Donc, pareil, me donne cette 1 minute pour screenshot these notes. Okay, let's continue. So this was the first example que nous servi area. Now, let's have a look at another example. Donc, toujours exemple. In the diagram, arcs AB and CD are arcs of concentric circles center O. If OA is equal to 6 centimeters AC is equal to 3 centimeter and the area of sector AOB is equal to 12 centimeters square. Calculate, donc first part, angle AOB in radians, and part B, the area and perimeter of the shaded region. Ok? Donc, c'est quoi, avant de ce dessin, c'est quoi the meaning of concentric circles? So, c'est quoi? Concentric circles, these are circles that have a common center. So, you have a circle, another circle. All these circles have a common center. So these are known as concentric circles. Ok, donc maintenant, let's come back to the question. Donc, dessin qui donne nous is this. So this is O, the center, B, D, A, and this part C. OA is 6 centimeters. Here, dans question interview. AC is equal to 3 centimeters. So this part is 3 centimeters. And the area of the sector AOB is equal to 12 centimeters square. So we need to find this angle. Angle AOB in radians. So we have the radius, we have the area, and we need to find the angle. So let me write it. Area we know, radius we know, and the angle is unknown. So from these two formulas, half r squared theta and half rs, formule qui est plus appropriée ici, c'est this one. Because we have r and we have theta. Sorry, the second formula is half rs for area. Yes, donc, sorry for this mistake. A is equal to half r squared theta. Les plus approprié parce que nous avons r, nous avons a, and we need to find theta. Donc, let's use it to solve for angle AOB. So for the first part, let angle AOB be theta radians. So we'll denote this angle as theta. So the area of sector AOB is given to us as 12 centimeters square. And we will use the formula half r squared theta to find theta. So we know that r is equal to 6 centimeters. So we replace the value of 6 in the formula, times theta is equal to 12. And therefore theta would be equal to 12 times 2 over 6 squared. Donc finalement, we have 12 times 2 over 36. Then theta would be equal to 2/3 radians. Donc the angle AOB is equal to 2/3 radians. This was the first part. Now the second part of the question, part B. So part B of the question, it demands to find the area of the shaded region and the perimeter of this shaded region, that is the region ABCD. Okay, so first we will find the length of OC. So let me take the drawing. Donc avant de continuer, please take a screenshot of the screen. So let's continue with the second part of this question. That is to find the area and the perimeter of the shaded region. Donc, pour ne pas find area of the shaded region, nous pouvons prendre area of the sector OCD minus the area of the sector AOB. Okay, là qui nous get the area of the shaded region. So first, let's find the area of the sector OCD. Donc area of sector OCD would be half r squared theta. Now what is r in the sector OCD? R would be OC. Donc half OC squared theta times theta qui nous fait trouver dans first part. Donc theta is equal to 2/3 in the first part. So OC is simple. OC is OA plus AC. Donc half of 6 plus 3 times theta, which is 2/3. Okay, so now we can simplify. It becomes half times 9 times 2/3. This cancels out. So, sorry, 9, this is to the square. So this is going to be 3 squared. Actually, no. Donc, let's do it again. That's going to be half into 9 squared times 2/3. Donc, these cancel out. 81/3, which is equal to 27 centimeters squared. So this is the area of the sector OCD. And we already know that the area of the sector AOB is 12 centimeters squared. Okay, this is given to us. Donc finalement, it's easy for us to find the area of the shaded region. We simply have to subtract the area of the bigger sector minus the area of the smaller sector to get the area of the shaded region. Donc, therefore, area of shaded region is equal to the area of sector OCD minus the area of sector AOB. Donc OCD, we just found qu'il est 27 centimeters squared, and the area of sector AOB is 12 centimeters squared. Here. Donc, therefore, the area of the shaded region is 15 centimeters squared. Donc, dans part B, we managed to find the area of the shaded region. Now we have to find the perimeter of the shaded region. Donc, to find the perimeter of the shaded region, we have to find AB, we have to find CD, parce que nous avons the value of the arc length AB and the length of the arc CD. But we do know that the value of AC is equal to the value of BD is 3 centimeters. Donc ce qu'il nous reste pour trouver c'est AB and CD. So how are we going to find these? So first, let's find the value of arc AB. Arc AB would be equal to r theta, because we know the formula S is equal to r theta qui nous trouvait at the start. Donc, what is r here? R is OA, and theta we already know. The value of OA is 6, and the value of theta is 2/3. Donc, therefore, the length of arc AB is equal to 4 centimeters. Nous faire pareil pour arc CD. So for arc CD, we will use the same formula. S is equal to r theta. Mais à la place de OA, we will have OC is times theta. And OC is equal to OA plus AC. Donc 6 plus 3 is 9 centimeters. Donc that would be 9 times 2/3, which is equal to 6 centimeters. Donc maintenant, we can easily find the perimeter of the shaded region. So the perimeter of the shaded region would be AC plus CD, AC plus CD plus BD plus AB. Donc AC is 3, CD is equal to 6 centimeters. BD, donc what is BD? BD is also equal to AC, which is 3 centimeters. And arc AB, nous trouvons qui est égal à 4 centimeters. Donc finally, when we add all of them, we will get the length is the perimeter of the shaded region to be equal to 16 centimeters. Okay, donc take a screenshot of the screen. Okay, let's continue now. So that was an example. Maintenant, nous faisons un exemple plus compliqué. Could nous savez tout ce que nous apprendre from the start. Length of arc, the use of the radian, the area of a sector. Okay, so let's have a look at examples. The diagram shows a circle, center O, radius 5 centimeters. The tangent to the circle at A meets OB produced at T. Given that the length of arc AB is 6 centimeters, calculate the area of the shaded region. Correct to 2 decimal places. So we have a circle. The center of the circle is O. Okay, so the center of the circle is O. This is A, this is B, and it says that A meets OB produced, donc OB produced at D. Given that the arc, donc at the start l'interno key radius is 5 centimeters, donc OA is 5 and OB is also 5 centimeters, and the length of the arc AB is 6 centimeters. So we know that this is 6 centimeters. And OA is 5 centimeters. So as we can see that we have a right angle triangle here because AT is a tangent to the circle at A. Donc tout le temps quand je tiens une tangent to a circle at a point, lean 90 degrees with the radius of the circle. Okay, so we have to find the area of the shaded region. The shaded region is this part. So here. So to find the area of this shaded region, we will first have to calculate the area of the right angle triangle OAT, and then we will have to calculate the area of the sector OAB. Donc là, nous prend area of triangle minus area of the sector OAB to get the area of the shaded region. Okay, il est un peu similaire comment the last example. So to find the area of the triangle and as well as the area of the sector, we will have to find this angle here, angle AOB. Donc, to find angle AOB, first let's call this angle theta radians. Donc, let angle AOB is equal to theta radians. So this is theta. And now, the value of theta, we will make use of the formula S is equal to R theta to find the value of theta. Because we know the value of S and we know the value of R, so we can easily find the value of theta. So theta would be equal to S over R, and S is given to us as 6 centimeters, R is 5 centimeters, so theta is equal to 1.2 radians. Okay, now to find the area of the triangle, we know that it is half base times height. Donc nous pas the value of the base, that is 80. So how to find the value of 80? Puisque c'est un right angle triangle, we can make use of trigonometry. Okay, donc un petit aperçu de trigonometry, donc note. This applies for right angle triangles. So if I have a right angle triangle, this angle is theta. The side opposite to the angle is called the adjacent. The side opposite to the angle theta is called the opposite side. The side opposite to the hypotenuse, the right angle, is the hypotenuse. And the last one is called the adjacent. So we have trois relations dans trigonometry for right angle triangles. These relations can be remembered using so, ka, to. Donc the sine of the angle theta would be equal to the opposite side divided by the hypotenuse. This is the first relation. The second one, the cos of the angle theta would be equal to the adjacent side divided by the hypotenuse. So the adjacent would be this one divided by the hypotenuse. And the tangent tan of the angle theta would be equal to the opposite side divided by the adjacent side. So now we have three formulas for trigonometry. We have to use one of these to find the value of 80. Okay? Donc, let's identify qui nous connaît et qui nous pas connaît dans this triangle that is given to us. So, we have 80. Yes. So, we need to find this angle theta. Okay, no, pas nécessairement. This angle theta, its opposite side is 80. Donc, and the side opposite to the right angle is called the hypotenuse. And the radius is the adjacent side. Donc, we have the angle theta, qui est trouvé the 1.2 radians. And we also have the adjacent side, which is the radius 5 centimeters. Donc, we have opposite and we have adjacent. Donc, when we have opposite and adjacent, we make use of tan. Donc, tan of the angle theta, tan theta would be equal to opposite over adjacent. This implies that the tan of this angle AOB is 1.2 radians. Donc 1.2 radians is equal to the opposite side, that is 80, qui nous besoin pour find the area of the triangle. 80 is the base of the triangle, over the adjacent, which is 5 centimeters. So therefore 80, we cross multiply, is equal to 5 tan de 1.2 radians. Okay? So now we find what is the base of the triangle. So we can easily find now the area of the triangle. Donc avant de continuer, take a screenshot of this part. Okay, let's continue. So now we have to find the area of the triangle and the area of the sector, AOB. Quand on finit find ça des area là, we subtract them to find the area of the shaded region. Alright, so here. Area of the shaded region is equal to the area of triangle OAT, okay, the right angle triangle, minus the area of sector AOB, so this sector here. Okay, so the area of triangle AOT, we know that it's half base, the base is 80 times height. The height of the triangle is OA minus the area of the sector. Donc là, comment se trouver pour area of sector? You can either use A is equal to half R squared theta or A is equal to half RS. Because the déjà connaît the value of R, the value of S, that is AB is equal to 6, and the value of theta. So you can use any formula. So here let me use, for example, half RS. Donc minus the area of the sector AOB, donc half R, the radius is OA, and S, that is the length of the arc, is AB. Donc maintenant, me replace, it's going to be half 80. 18 in fact trouve value leaving 5 tons of 1 decimal 2 radians. Donc avant de continuer, quand c'était là pour évaluer tan of an angle or any trigonometric function of an angle which is in radian, your calculator should be in radian mode. Okay? Toujours, je te mets cette calculatrice low radian mode. Donc là, les bouvines, 5 tons, 80 is 5 tons of 1 decimal 2 radians. The radius OA is 5 centimeters minus half OA, which is 5 centimeters, and AB is 6 centimeters. So when we simplify, the answer becomes 17.15 centimeters squared. Okay? So before we continue, please take a screenshot of this last part. Ok, donc on arrive à la fin de cette session. Est-ce qu'il y a une question so far? Do you have any questions? Je peux unmute ou je peux send cette question par chat. Anyone? Une inquiétude qui est particulière pendant session 1 ou une inquiétude qui se pas comprendre that you want to clarify?
Non, correct.
Allez, ok. Donc, c'est bon pour tout le monde. Alors, donc, merci, Jonathan, this session. J'espère que vous êtes en train de cette session-là, un peu l'eau cyclométrie et un peu l'eau trigonométrie. Donc, c'est tout pour aujourd'hui et bonne soirée à tous.
Merci, madame. Au revoir.
Au revoir.